Okay, so bacho, the new topic is alcohols. Alcohol is one new homologous phrase that we need to discuss. And few of the things about alcohol, if you remember that if you talk about alkenes, so we convert alkenes into alcohol, right? We already convert alkenes into alcohol, and we know that that was electrophilic addition reaction. That was electrophilic addition reaction, and the reagents what, like we were using dilute phosphoric acid over there along with steam, right? And the conditions for that reactions is 350 degrees Celsius temperature and 100 atmospheric pressure. So this is what we convert alcohols into alkene, right? And we also talk about the conversion of alcohols back to alkenes, and that was like dehydration reaction, or you can say that this was like elimination of water molecule, right? This was like elimination of water molecule, and for this the conditions was like you can use concentrated sulfuric acid along with 200 degrees Celsius temperature, or the alternate conditions was aluminum oxide can also be used to do this work at 350 degrees Celsius temperature. Right, Bacho? We have done this, right?
Yes.
Then, if you remember the last chapter, we also talked about the conversion of halogenoalkanes, the conversion of halogenoalkanes into alcohols, right? We also done this in the previous chapter. We can even convert halogenoalkanes into alcohol, and that was like it was nucleophilic substitution reaction. It was nucleophilic substitution reaction. Nucleophilic substitution reaction, and for this type of reaction, the reagent was quite important to remember. We were using NaOH aqueous. NaOH aqueous means the solvent is actually water, right? The solvent is actually water. You need to keep remember this, and heat under reflux was the condition. Heat under reflux for the complete reaction, right? So these are the things that we already talk about, something about alcohol. Now we are officially going to start the chapter alcohols, right? So if you talk about alcohols, but just the journal formula for this family is, you can say that journal formula should be CnH2n plus 1 OH. OH is actually the functional group for this family. And if you want to write the journal formula in this way, so you can even like 2n plus 2 and O. You can even write the journal formula in this way. And the OH, why I just write OH separately, so it will be easier for you to identify कि यार ये functional group है alcohols का. ठीक है. So let's start alcohols. So if you talk about the molecular formulae, right? So we can find out the molecular formulae by journal formula, right? Any one of the journal formula, you can see this, that it is CnH2n plus 1, right? OH. So if I use that, so it will be C1. So carbon will be 1, and H will be 2, 1's a 2 plus 1, 3, and along with OH. Then again, C2, 2 2's a 4 plus 1, 5, OH, right? Then C3, 2 3 is a 6 plus 1, 7, and then OH. Then C4, H9, OH. These are what molecular formulae of the substances that are actually the part of alcohol family. Then, but so if you talk about displayed formulae, so we know that in displayed formulae, we must need to show every single bond present over there, every single bond, right? So for suppose if you are drawing the displayed formula of this compound and you draw like this, a carbon having 3 bonds with individual hydrogens and then 1 with OH, this will be wrong, right? So you must need to show over there that there is a bond between O and H as well, right? There is a bond between O and H as well. You must need to show this, right? And then if you talk about the two carbons structure, so it will be like this. You can set OH anywhere on the first carbon, right on the right hand side, on the first carbon on the left hand side, anywhere else. That's the same thing. But if you talk about this structure, when we have three carbons, right? So if you put OH over there, that's fine. Or if you put OH over here, that's the same thing, right? This is what propane 1-ol. This is what propane 1-ol. But the thing can be different if you put OH on the second carbon. For suppose, if I just remove this one from here, so we can even put OH on the second carbon like this, 1, 2, 3, and for suppose H's are over here, and we just place OH on this carbon. So this will be propane 2-ol now. This is a different thing, right? So this is, you can say that the isomer of positional isomer of propanol, right? So this is propane 1-ol because the functional group is on the first carbon, and this is what propane 2-ol because the functional group is on second carbon, right? So same as it is if you talk about the third thing, which is condensed formulae. Condensed formulae. So they are again the same thing. You need to put on every hydrogen connected with carbon, right? So over here you can see this, that 3 hydrogens are consecutively connected with a single carbon and then OH, and over here first 3 hydrogens are with the first carbon, and the next 2 hydrogen and 1 OH is with the second carbon. And over here it will be CH2 OH, then CH2 and CH3. Over here you need to write like this, CH3, फिर एक कार्बन के साथ हाइड्रोजन है, and क्योंकि अब बीच में आ गया है OH, so you can use a bracket over here कि ये भी इस कार्बन के साथ है, and then CH3. Is that right, every one of you?
Yes,
Yes, sir.
Then we have a skeletal formula as well. Skeletal formula is something different. You need to show the carbons over here. So remember, a single dot for a single carbon. So over here, this is a single dot for a single carbon, but you need to show the OH over there as well. So it will be mentioned that this is methanol, right? And over here we have 2 dots. It's showing 2 carbons and then OH, right? So this is ethanol. And for example, over here, 1, 2, 3 carbons and then OH over here. So this is propane 1-ol. And over here, 1, 2, 3 carbons, and over here it is OH. So you can say that it is propane 2-ol. Is that right, every one of you?
Yes, sir.
So if you talk about name of these substances, so we must remember the prefix and suffix of this. So how many prefixes we have? We know that we need to know about 1 carbon is always meth, right? And 2 carbon, it is always eth. And for 3 carbons, it is always prop, right? And for alcohol, we always talk about alcohol over here. So alcohol mein aakhri mein OL aa raha hai. So this is actually the suffix of this family, right? But propol is अजीब सा लगेगा थोड़ा सा, तो इसको बनाने के लिए हमने an का यूज किया है. So this is propanol, ethanol and methanol, right? So you can say that कि all नहीं यूज करेंगे आप, अल्कोहल में आप यूज करेंगे actually anol, right बच्चों? और अगर इस तरह बीच में कहीं आपके पास आ जाए, so you can mention it over here, the number of carbon where the functional group is present, or you can even say that it is 2-propanol. You can even write like this, 2-propanol. That is also fine. That's right? And these are actually positional isomers when the position of the functional group is changing. This is positional isomers of alcohol. And you can see this, that if you talk about the homologous race properties, so the thing you need to keep remember is journal formula. Every compound over here is following this journal formula. So this is the first property of homologous series. If you want to be in any homologous series, so the substance should follow the journal formula. So you can see propanol, methanol, ethanol, everyone over here, what I draw over here on the screen, everyone is following journal formula. that's fine. Then this is the functional group, and which is very much important. The next thing in the homologous series, if you want to be in alcohol family, so you must have OH functional group now, which is hydroxyl. This is not hydroxide. Remember, this is hydroxyl बच्चों. इसको हम बोलेंगे हाइड्रोक्सिल. जब कभी भी आपके पास कोवेलेंट बॉन्डिंग के साथ अटैच होगा ना OH, तो that will be hydroxyl. So this is hydroxyl. तो अल्कोहल में आप देखें, every one of them, methanol, ethanol, propanol, every one of them having what? Hydroxyl with them, right? And the third chemical properties are similar, and we will talk about this. And if you talk about physical properties, so you can see this when the number of carbon increases, so definitely their melting point, boiling point, their state, their color, everything is going to be changed. And only the thing which is going to be different is, or decreasing, is flammability and volatility. When you move down the group with the greater number of carbons, so you can say that volatility decrease hoti hai or flammability decrease hoti hai, and the rest of all properties are going to be increased. Melting point badhega, boiling point badhega, density badhegi, molecular mass badhega, सब कुछ बढ़ेगा, but the capability, you can say that the उनकी जो ability है to burn them out is going to be decreased, और उनकी जो ability है to evaporate at room temperature will be decreased. Volatility or flammability decrease होती है. And then the last point is, between two consecutive members there is a difference of CH2. You can see this, between every two consecutive members there is a difference of bond CH2. एक bond बढ़ेगा और CH2 उसके साथ बढ़ेगा. Is that right, every one of you?
Yes, sir.
Okay, so now your task is, you need to do for
Sir,
butanol. जी बेटे.
sir, flammability will be decreasing, right, as we go down the group?
Yes, flammability and volatility. These two things are going to be decreased. अच्छा देखें, flammability के साथ हमारा जो है concept थोड़ा सा खराब होता है कि हम समझते हैं कि flammability का मतलब ये है कि अगर वो जलेगा तो वो जो है ना कम एनर्जी प्रोड्यूस करेगा. ऐसा नहीं है. फ्लेमेबिलिटी का मतलब ये है कि जब आप उनको जलाएंगे तो उसमें टाइम ज्यादा लगेगा और उसमें एनर्जी ज्यादा लगेगी. डेफिनेटली अगर आप मीथेन गैस को बर्न करते हैं अपने घरों के अंदर तो मीथेन गैस जल्दी बर्न हो जाती है और वो एनर्जी भी कम ही देती है जलने के बाद. लेकिन अगर आप पेट्रोल को देखें कार्स के अंदर तो वो थोड़ा सा देर से जलेगा बट वो ज्यादा एनर्जी देगा. अगर आप डीजल को देखें ट्रक्स के अंदर तो वो थोड़ा और देर से जलेगा. उसको जलाने के लिए बड़ा इंजन चाहिए तो वो और उसको जो है ना एनर्जी चाहिए जलाने के लिए, और फिर जब वो जलेगा तो फिर वो एनर्जी भी उस हिसाब से ही देगा. तो फ्लेमेबिलिटी इज समथिंग वी रिक्वायर्ड एनर्जी टू ब्रेक देम ऑल द बॉन्ड्स ओवर देयर, राइट. तो उनको जलाना थोड़ा सा डिफिकल्ट हो जाता है जब बॉन्ड ज्यादा हो जाते हैं. ठीक है, राइट बच्चों?
यस सर.
तो आपको क्या करना है बच्चों, आपको ब्यूटेनॉल और पेंटानॉल के बारे में मुझे बना के दिखाने हैं ये सारे फॉर्मूला, एंड आल्सो यू नीड टू ड्रॉ द आइसोमर्स ऑफ ब्यूटेनॉल एंड पेंटानॉल, द पॉसिबल स्ट्रक्चर्स ऑफ ब्यूटेनॉल एंड पेंटानॉल. कितने आइसोमर्स आप बना सकते हैं, लेट्स सी. चलें स्टार्ट कीजिए. तो अब देखो यहाँ पर हमारे पास ये बहुत इंपॉर्टेंट चीज है जो अभी मैं ऐड करने जा रहा हूँ इसके अंदर. दिस इज ऑल अबाउट प्राइमरी, सेकेंडरी एंड टर्शियरी alcohols. Like we talk about this in carbocation as well, we talk about this in halogenoalkanes as well, and the same thing will be here as well, right? Primary alcohols, right? Secondary alcohols, and tertiary alcohols, right? अच्छा देखो ये क्यों इंपॉर्टेंट है, क्योंकि इनके रिएक्शंस डिफरेंट होते हैं ना. जब भी वो आपसे पूछेगा ना राइट डाउन द नेम ऑफ द होमोलोगस सीरीज या द फंक्शनल ग्रुप्स प्रेजेंट इन द कंपाउंड, वो पूछता है इस तरह का सवाल ना. तो वहां पर अगर आप अल्कोहल डिफाइन कर रहे होंगे तो वहां लाजमी आप इनकी प्राइमरी, सेकेंडरी और टर्शियरी डिफाइन करेंगे. लाइक क्योंकि अगर आप सिर्फ अल्कोहल लिख देंगे तो प्राइमरी अल्कोहल के रिएक्शन डिफरेंट हैं, सेकेंडरी के अलग हैं, टर्शियरी के अलग हैं, या नहीं करता है टर्शियरी. ठीक है ना. तो यू नीड टू रिमेंबर दिस कि जब कभी भी अल्कोहल फंक्शनल ग्रुप अगर आप किसी आंसर में डिफाइन कर रहे होगे तो वहाँ यू मस्ट नीड टू डिफाइन कि वो अल्कोहल प्राइमरी है, सेकेंडरी है, टर्शियरी. इट्स मस्ट, क्योंकि आपको 2 मार्क मिलेंगे. अदरवाइज अगर सिर्फ अल्कोहल लिख दोगे तो 1 मार्क मिलेगा. जब भी आपसे अल्कोहल पूछेगा तो इसकी आइडेंटिफिकेशन 2 मार्क्स की होगी. ठीक है ना. एंड द प्राइमरी, सेकेंडरी, टर्शियरी इज अगेन द सेम थिंग. जिस कार्बन पर आपके पास OH लगा हुआ है, जिस कार्बन पर आपके पास OH अटैच है, उस कार्बन पर आपके पास 2 इंडिविजुअल हाइड्रोजन्स होंगे एंड देन कार्बन की चेन होगी. I'm just considering this R as a carbon chain. This is known as alkyl chain. अब ये CH3, ये CH3 भी हो सकता है, ये CH3 CH2 भी हो सकता है, ये CH2 CH3 भी हो सकता है, ये CH2 CH2 CH3 ये कुछ भी हो सकता है. They all are R, which is known as alkyl chain. ठीक है ना, इस R को हमने इस तरह कंसीडर किया. देन सेकेंडरी में भी वही सीन है जो कि आपने कार्बोकैटाइन और आपने हैलोजन अल्केन में देखा था. द कार्बन व्हिच इज हैविंग OH इज कनेक्टेड विद टू अल्काइल चेन्स. दो तरफ फिर अल्काइल चेन हो सकती है, सेम भी हो सकती है, डिफरेंट भी हो सकती है, एंड इट जस्ट हैव वन इंडिविजुअल हाइड्रोजन, राइट, अकेला हाइड्रोजन. और फिर टर्शरी में भी वही सीन है जो कि आपने पहले किया था. जिस कार्बन के साथ OH अटैच है उसके पास 3 डिफरेंट अल्काइल चेन होंगी. 3 अल्काइल चेन होंगी, सेम भी हो सकती है, डिफरेंट भी हो सकती है. ठीक है ना. अब मैं इनको यूज करते हुए अगर मैं इनको यूज करते हुए क्या बनाऊं, इनको यूज करते हुए आइसोमर्स बनाऊं, तो जरा देखें. अगर फॉर सपोज वी जस्ट टॉक अबाउट ब्यूटेनॉल, अगर हम बात करते हैं किसकी, ब्यूटेनॉल की ना, so just look at over here, the first carbon having for suppose OH, right, और फिर यहाँ पर हमने ये जो बाकी कार्बन हैं, 3 कार्बन बचते हैं ना, फॉर ब्यूट मतलब 4, राइट. तो एक कार्बन तो हमने यहाँ बना दिया, इसके साथ हमने 2 H's बना दिए, राइट, और बाकी कितने बचे आपके पास, 3 कार्बन. सो इट विल बी अटैच ओवर हियर लाइक CH2 CH2 CH3. this is what this is primary alcohol. this is what primary alcohol. ठीक है ना. अगर वो इस तरह के आपके किसी मॉलिक्यूल आपको दे और आपसे पूछे what is the functional group present in these molecules, you must need to remember this कि आप सिर्फ अल्कोहल नहीं लिखेंगे, आप लिखेंगे वहां पर प्राइमरी अल्कोहल. ठीक है ना, ये आपने याद रखना है. देन अगर मैं इसका सेकेंडरी बनाऊं तो वो कैसे बनेगा, देखो, एक कार्बन है जिसके ऊपर OH लगा हुआ है, उस पर सिर्फ एक H हो सकता है और दो तरफ कार्बन की चेन होगी. अब टोटल हमें 4 कार्बन पूरे करने, तो राइट नाउ वी हैव जस्ट 1 कार्बन इन द सेंटर, तो 2 मैं इस तरफ कर देता हूँ, राइट, और मैं एक इस तरफ कर देता हूँ. तो दिस इज व्हाट, दिस इज 1 ब्यूटेनॉल, और ये क्या बन गया आपके पास बेटे, ये बन गया आपके पास 2 ब्यूटेनॉल. ठीक है ना. तो ये खुद ब खुद पोजिशनल आइसोमर बन गया, देखें. ठीक है ना. उसके अलावा अगर हम इसको टर्शरी बनाने की कोशिश करें तो देखें, एक कार्बन जिसके ऊपर OH है, इसके तीनों तरफ कार्बन की चेन होनी चाहिए. सो वी हैव ऑलरेडी only 4 कार्बन, सो एक एक कार्बन ही लग सकता है तीनों जगहों पर. सो इट विल बी व्हाट, CH3 CH3 CH3. नाउ यू कैन सी दिस, व्हाट इज द नेम ऑफ दिस स्ट्रक्चर. दिस इज like 2-methyl. On the second carbon we have methyl functional group or branch, right. This is, you can see this, the maximum number of carbon in the straight chain is 3, right. You must need to remember, जो आप long chain select करते हो उस long chain में functional group आना जरूरी है अल्कोहल का. ठीक है ना. और this is what branch. So you can say that count from anywhere, it will be on the second carbon. So this is 2-methyl and propane 2-ol. 2-methyl and propane 2-ol. This is another structure, you can say that, right. So 1 butanol, 2 butanol, and 2-methyl propane 1-ol. We can even draw the structure like this. Just look at over here on this structure. The carbon having 2 hydrogens, that's fine, and OH as well, that's fine. But वो जो हमारे पास ये जो 3 कार्बन हैं, इन 3 कार्बन पे अगर मैं ब्रांच बना दूं, so we can even draw like this. देखें, this is also one of the structures. You just look at over here. This is long chain, for suppose 1 2 3, and you can see this on the long chain I just selected hydroxyl as well, and now this is branch. All right, so you can say that this is first carbon because alcohol is, you can say that, have a priority. So functional group jahan kareeb hai wahan se start karenge. So this is 2-methyl. On the second carbon we have branch 2-methyl and propane 1-ol. This is propane 1-ol, right, every one of you?
Yes, sir.
Is that clear, every one of you? Yes, but